The geological explanation of the Niscemi landslide does not begin with collapse, but with accumulation, layers of soil, water, history, and pressure interacting over decades. Long before the ground moved, the conditions for failure were already written into the landscape, invisible to most, but relentless in their progression. What unfolded in January 2026 was not an anomaly, but the visible release of processes that had been unfolding beneath the surface for generations. A hill already in motion. Picture a Sunday morning in the heart of Sicily. The sky hangs low and swollen, clouds dragging heavy curtains of rain across the countryside. Niscemi, a town of roughly 28,000 residents, perched atop rolling hills of clay and limestone, begins to stir. But beneath its cobbled streets and pastel rooftops, an ancient instability is already awake. This part of southern Sicily sits atop Plio-Pleistocene clay formations, among the most landslide-prone geological materials in Europe. These clays expand when wet, lose shear strength, and can deform slowly for decades before failing catastrophically. According to Italian geotechnical surveys, over 90% of Sicily's landslides occur in clay-rich terrains, often following prolonged rainfall rather than single extreme events. In the 6 weeks preceding January 18, 2026, the region recorded more than 300 millimeters of rainfall, nearly twice the seasonal average. The soil became saturated, layer by layer. Groundwater tables rose. Pore-water pressure increased silently, reducing friction along ancient slip surfaces that had moved before, sometimes centuries earlier. At 8:43 a.m., the Earth finally responded. In mere moments, nearly 4 kilometers of terrain failed, cutting through both the outskirts and the historic core of Niscemi. Roads folded and disappeared. Retaining walls shattered. Buildings, homes filled with memory and routine, were torn apart. Some split cleanly in two. The sound was not explosive, but deep and continuous, a grinding, guttural roar as millions of cubic meters of earth began to slide. For the people above, it felt like betrayal. More than 1,500 residents were evacuated, many with minutes to spare. Infrastructure painstakingly maintained over decades, water lines, gas networks, fiber optic cables, was destroyed in hours. Entire neighborhoods were redefined overnight. A town square that had anchored daily life became a jagged fault line between stability and void. Shops that had stood for generations now hovered at the edge of fresh scarps. Roads engineered for safety vanished beneath displaced earth, and the movement did not stop. Over the following days, monitoring instruments recorded continued ground displacement of several centimeters per hour in some sectors. Slow enough to watch, fast enough to fear. Cracks widened, new fissures opened. Panic gave way to a more disturbing realization. The land itself could no longer be trusted. A known risk long ignored. This catastrophe was not the first to strike Niscemi. Historical records describe landslides here as far back as the early 19th century. Italy, as a whole, is the most landslide-prone country in Europe. Over 93% of municipalities are classified as at risk, and landslides cause billions of euros in damage annually. Sicily is consistently among the hardest hit regions. What made the 2026 event different was not its cause, but its scale and speed. Urban expansion had crept steadily onto marginal slopes. Drainage systems, designed for a drier climate, failed under sustained rainfall. Climate data shows that intense, prolonged precipitation events in southern Italy have increased by more than 20% over the past 3 decades, loading already fragile hillsides beyond their limits. This was not cruel luck. It was delayed consequence. The hills did not suddenly decide to move. They were pushed, slowly, patiently, by water, gravity, and time. Beneath our feet. Why did the land betray its people? What invisible hand guided the hills toward collapse? And, most hauntingly, is this the beginning of a new era? Not just for Niscemi, but for towns across the world, built on slopes assumed to be stable. The answer lies beneath our feet, in soils that remember every storm, in layers that record every decision to build, drain, divert, or ignore. Landslides do not erupt like earthquakes. They announce themselves quietly. through millimeters of movement, through cracks dismissed as cosmetic, through warnings easy to postpone. Niscemi's tragedy is a reminder written in earth and stone. The ground is never truly solid. It is only waiting. Let us journey through clay and rain, history and pressure, fact and fracture, to unravel the geological secrets behind the Niscemi landslide. Because what lies beneath is not just geology, it is the future, asking whether we are ready to listen. The gathering storm, how Cyclone Harry set the stage. The roots of the disaster stretch back to January 18th, 2026, a date as ominous as it was significant. That winter brought a relentless wave of severe weather to southern Italy, battering Calabria, Sardinia, and Sicily with a sequence of tempests, the likes of which few could recall. At the heart of it all was Cyclone Harry, a storm that would leave scars the island would not soon forget. On the night before the disaster, torrents of rain lashed Niscemi. For hours, sheets of water pounded the hills, pelting clay-rich soils and fractured rock with a violence rarely seen, even in the stormy annals of Sicilian history. Locals huddled inside, listening to rain strike roof tiles and wind howl past the olive groves. Muddy water gushed down ancient streets, filling cellars and pooling in low-lying gardens. Riverbeds swelled beyond their banks. Water curled around foundations and crept into every crack, saturating the earth to the breaking point. Fields became temporary lakes, their broad surfaces reflecting only the dark, roiling clouds above. On hillside farms, animals were moved from slopes in haste. Some residents risked the storm to pile sandbags, while others placed their nervous trust in foundation stones and in prayers handed down from generations. But it wasn't just rain. It was a calculated assault by forces greater than any individual storm. Cyclone Harry ranked among the most damaging storms the region had experienced in a century. Wind stripped tiles from roofs, uprooted ancient olive trees, and drove debris across fields and roads. Farms and vineyards were drowned beneath water and sediment, and roads transformed into sudden torrents. But perhaps most crucially, a more sinister transformation was underway, unseen below the surface. All that water pressed down into the earth, infiltrating every crevice, parting molecules apart, finding faults invisible to the naked eye. The weight and pressure began to yield soil and rock, pushing them to the limits of their endurance. Beneath the visible world of busy streets and daily life, faults and fractures that had lain dormant for centuries found themselves saturated. The hills whispered warnings, soft, nearly imperceptible hints that their strength was vanishing. No one saw the drama unfolding underground. Water forced its way between plates of clay and silt, opening the ancient fissures farther with every drop, lubricating weak layers until the mountain itself was poised on a knife edge. All it awaited was a final trigger. Would it be another burst of rain, another surge in the water table, a subtle seismic jolt, or simply the weighted balance tipping toward catastrophe, a final, perfect alignment of stress and weakness? For Niscemi, that question was answered by cold, implacable geology. Rock's fatal flaw. Amid the shattered aftermath of Niscemi, it is easy to think of the Earth as a solid, trustworthy foundation. But the truth, as geologists and environmental experts agree, is more sobering. Rock has limited strength, and in reality, rock has particularly bad strength. It is an unsettling paradox. The ridges around Niscemi seem ageless, carved and shaped for millennia, proud and defiant as they reach for the sky. Yet every layer, every contact between stone and soil hides vulnerabilities built up through countless cycles of pressure and change. Fractures accumulate, minerals dissolve, microfaults hide beneath the dust, each a hidden threat waiting for the right conditions. With Cyclone Harry's deluge, these fractures yielded, water entered, forcing grains of rock apart, building invisible pressure. The rock's chemistry, possibly rich in swelling clays or weakened by countless past shifts, became its undoing. But why is rock strength so limited? Because every stone is a composite. Millions of tiny mineral bonds, like links in a chain. Break enough links and the chain fails. Damage builds slowly, almost invisibly, for decades or centuries. Then, in an instant, everything falls apart. The weather and movements of the days leading up to disaster were quietly pushing Niscemi toward its breaking point. The hills, destabilized by past landslides and ceaseless Mediterranean weather, were preparing for collapse. Did the Earth warn us? Were there subtle cracks in roads, slow tilts in the foundations, signs buried in daily life that disaster approached? Or are these moments of geological weakness forever destined to surprise us, breaking trust with no clear warning? Translational sliding, nature's relentless blade. The catastrophe at Niscemi was not an ordinary slump of mud or rock. It was a translational landslide, a phenomenon both precise and devastating. Imagine a massive sheet of hillside, poised for centuries above a modest incline, suddenly set free to slide along a nearly horizontal bedding plane. That is translational sliding, a clean, forceful movement along a slick or unconsolidated layer. Rather than tumbling and mixing, the ground moves almost as a single colossal unit, its top gliding above a weakened surface. Such sliding is distinct, the difference between a mudflow's slow churning and the streamlined, aligned rupture that happened here. At first, a single road, Via Gela, the vital link to the Gela-Catania State Road, showed the strain. Tallied cracks spread, then widened, buckling tarmac in waves and cutting the town off. But the movement spread beyond the road, drawing in buildings, fields, and gardens in its widening grip as the days and rain continued. How does a translational slide start? It's a matter of balance, of friction lost and gravity asserting itself. When a lubricated, saturated layer of clay or silt beneath the surface gives way, the heavy load above cannot hold. Everything above slides, unchecked, driven by the mass of waterlogged earth and the inexorable pull of gravity. In Niscemi, the sheer scale was staggering. 4 kilometers of land moved together, splitting homes, swallowing gardens, uprooting trees. Ancient retaining walls collapsed, new escarpments opened overnight. Foundations slipped. Furniture and treasures were left precarious at the edge of sheer drops. Roads and footpaths vanished or twisted beyond recognition. For many, the event was almost incomprehensible. Over 1,000 residents watched as the town's boundary was literally redrawn, homes and livelihoods erased in a matter of hours. The Earth's power had rewritten history and forced a new respect for the invisible mechanics at work beneath our feet. Is it really just a matter of water and weak rock? Or does this disaster reveal that enormous, patient forces have always lurked below, ready to remake the landscape whenever the right combination of rain, rock, and gravity arrives? When history repeats itself. To an outsider, Niscemi's landslide may seem like a once-in-a-lifetime tragedy, an unforeseeable calamity. But in truth, landslides are part of Niscemi's long story. Sicily's hills, battered by wind and rain for millions of years, are anything but uniformly solid. For more than 200 years, the people of Niscemi have lived with the constant possibility of the ground moving. Local legends tell of the night of the falling earth, of fields and homes lost, sometimes overnight. Sometimes these slides are slow, creeping for years. Other times, as in 2026, the ground gives way in an instant. Why does this happen again and again? Sicily's unique geology offers one answer: a blend of clay, sand, and fractured limestone, a landscape both beautiful and fraught with latent danger. Beneath the sunlit surface lies a labyrinth of faults, seams of slippery clay, and layers weakened by time. Stability is always temporary, always conditional on the mercy of the weather. Each landslide leaves wounds, earth torn, deep lacerations that later become fresh points of weakness. Repaired roads and buildings may cover the scars, but rarely heal them. Under every new layer of asphalt or brick, the hidden damage persists. Niscemi's earth is a palimpsest, a scroll rewritten by every disaster, each new landslide etching more fragility into the future. The 2026 collapse that forced 1,500 from their homes echoed earlier calamities, and the difference now is a matter of intensity and frequency. As climate patterns shift, storms intensify, and the built environment grows, the risks multiply. New cracks appear each year, warnings abound, even as time between disasters shrinks. Does history doom Niscemi to endless repetition of loss? Or is there still an opportunity to break this dangerous cycle? The climate emergency, a catalyst unleashed. For generations, Niscemi's people have read the weather as prophecy. Today, however, the rules are changing fast. Rains are heavier, storms more destructive, and the delicate balance of nature has been violently upset. Geologists and environmental experts point to a single, relentless truth. The landslide in Niscemi is the latest sign of how the climate emergency is reshaping the land. Gone are the days when winter rains could be counted on to nurture fields without destroying them. The climate emergency has raised the stakes and rewritten expectations. Storms as fierce as Cyclone Harry, once rare, are now all too common. Downpours come in record-shattering volumes, overwhelming an already vulnerable landscape. Ordinarily, Sicily's soils and rocks would soak up rainfall gradually, letting water filter into aquifers and streams. Now, rainfall smashes onto hillsides with such speed and volume that the ground is saturated in mere hours. There is no time for natural drainage. Water builds, pressure mounts, and, soon enough, the earth gives way. With each passing storm, cracks widen in bedrock. Weaknesses accumulate, making the land more prone to future collapse. Rising groundwater seeps into the layers beneath, softening clay, shattering stone, undermining already fragile foundations. As the planet warms, every additional degree tips the scales further against towns like Niscemi. A warmer Mediterranean means more frequent and more intense storms. Cyclone Harry was just one chapter in a broader trend linking Niscemi's future to the fate of a changing planet. Is the catastrophe inevitable, written in the choices of distant nations and the realities of a warming climate? Or can adaptation, new policies, and local resilience yet stem the tide of loss? The human toll, a town divided. In the aftermath, the silence was as haunting as the collapse itself. Niscemi's people were left not only with questions, but with the painful sight of their own town in upheaval. Entire buildings had been split by the slide, one half standing, the other torn away. Streets once filled with children and bustle, now blocked by fissures and collapsed earth. Over 1,500 people, suddenly displaced, became refugees not in a distant land, but in their own battered community. Families fled with barely a moment's warning, clutching what little they could. For many, returning after clearance, their homes were rubble, furniture shattered, possessions gone, generations of memories entombed in silt or exposed on new cliffs. Schools and community centers became temporary shelters, islands of anxiety and hope. With roads cut, supplies grew scarce. Volunteers and officials struggled to reach isolated neighborhoods. Some blamed fate, others sought scientific answers, and some questioned if the disaster could have been foreseen or averted. The psychological scars ran deep. What does it mean to lose trust in your home, in the ground beneath your feet? How does a community recover when permanence itself feels like a broken promise? Restoration efforts began swiftly, with teams racing to reconnect critical roads, especially the vital Gela-Catania route. Surveyors probed the ground with sensors and drones, mapping new fault lines and measuring risks. Yet, for many, trust had been broken. Trust in the land, in the systems designed to protect them, in the very idea that home is safe. Can a town truly rebuild when the ground must now be watched as closely as the sky? How do you restore confidence after the foundation itself has betrayed you? The story of the Niscemi landslide is written in mud, memory, water, and resolve. The ground where faith once stood now demands understanding, a hard-won respect born from disaster. With eyes open and minds prepared, perhaps the next time the earth whispers, we will be ready at last to listen and to act before the ground moves